Okay, 5.4. Here we're going to talk about equilateral and isosceles triangles. So if we go back to that front page, we have those two different triangles that we talked about before. And now we're just going to go into more depth, okay? So the first vocab word, it doesn't show up here, but it is legs. And it is the two sides of an isosceles triangle that are congruent. Okay. Oh, I'm sorry, I feel like this looks kind of weird. Here we go. Better. Okay, the next one is vertex angle. And it is the angle formed by the two legs. Okay, so we're going to go ahead and pause here, and I'm actually going to have you draw an isosceles triangle, okay, to the best of your ability. Okay, so that means that this would be a leg, and this would be a leg, and this angle right here is the vertex angle. Okay, so then the next thing that we have is base, and it is the third side of an isosceles triangle. Okay, so this side down here is the base. Then we have base angles. It is the two angles adjacent to the base. Okay, so this angle and this angle would be base angles then. Okay. Theorem 5.6, the base angles theorem. We have if two sides of a triangle are congruent, then the sides, then the angles, got too far ahead of myself. And then the angles opposite them are congruent. Okay, so if I'm looking here, this side is congruent to this side. So if I go down, kind of like diagonally down from here, okay, B opens up to make this side AC. And then here I have C opens up to make AB, and it's the same as AC. So that means that these angles have to be the same as well. Okay, so base angles are congruent is what you can conclude there. Okay. Okay, and you might want to add that in here. So summary, base angles of isosceles triangle are congruent. Okay, then in theorem 5.7, okay, we have the kind of going the opposite since it's the converse. If we remember, it's going to go in the opposite way. If two angles of a triangle are congruent, then the sides opposite of them are congruent. Okay, so then this way, this summary, you know if these two angles are congruent, then you know this side is congruent to this side. Okay, so if base angles congruent, then it is isosceles. Okay, all right, in example 1, in triangle DEF, segment DE is congruent to segment DF. Name the two congruent angles. Well, opposite of ED is angle F, and opposite of FD is angle E. Okay, so that's all you need there. Okay, on this one, it says if HG was congruent to HK, then angle, well, what's across from HG is angle K. What's across from HK is angle G. Okay, the next one is if KHJ, so KHJ, so it's this angle here, is congruent to KJH, this angle here. Now, what two sides are congruent? Well, the side angle opposite of angle J would be KH, so segment KH is congruent to segment KJ. Okay, that's all that you need there. We're going to turn the page. So the next thing is to recall an equilateral triangle has all three sides congruent. Okay, 5.2 corollary to the base angles theorem that says that if a triangle is equilateral, then it is also equiangular. Okay, so what that means is if three sides are congruent, then three angles are congruent. Okay? All right, so now the corollary to the converse of the base angles theorem says that if a triangle is equiangular, so basically going the opposite way, if a triangle is equiangular, then it is equilateral. Okay, you're allowed to go both ways. So this one would be if three angles congruent, then three sides are congruent. Okay? All right. So in example 2, we have finding the measures in a triangle. So it says find the measures at an angle P, Q, and R. So we've actually already talked about this, and I kind of gave you the answer before you really needed it. So I know that all of these angles are the same. So if I just call one of them X, or if I call all of them X, since I know that they're the same, I have 3X is equal to 180. Which means that X is equal to 60 whenever you divide by 3. So the measure of angle P is equal to the measure of angle Q, which is equal to the measure of angle R, which are all 60 degrees. Okay. Next one, number 3, find the length of segment ST for the triangle at the left. You know that SU is the same as UT, which is the same as ST. Okay, and since UT is 5, then you know that ST is also 5. Okay, example 3, find the values of X and Y in the diagram. So if I look at this top triangle, okay, I'm going to cover up this one. I see that this one has a Y and this one has a 4. Okay, clear that up a little bit for you. Okay, so I see a Y and a 4, so that means that if this is equiangular, that means that this is also equilateral. So that means that Y is equal to 4. Okay, so then if I cover up here, I know that this side is 4, this side is 4 now. So now I have, if I cover up this one, I have an isosceles triangle. Okay, so I know that X plus 1 is equal to 4. Subtract 1, and you know X is equal to 3. Okay, so there are the two that you need there. All right, we got one more page of notes still. Example 4, solving a multi-step problem. So the lifeguard tower segment PS is congruent to segment QR. So P to S is right here, is congruent to QR. And angle QPS is congruent to angle QPR. Okay, so if I wanted to, and I'm going to because I think it makes life so much easier, whenever you separate these triangles and draw them out on a piece of paper, I think it makes it a lot easier to see. Okay, again, it doesn't have to be perfect. Okay, but now I can show you more clearly that those are the same. Okay, and then it gave you this one and this one. Okay, so on part A, it says, explain how to prove that triangle QPS is congruent to triangle PQR. So on part A, you know that PS is congruent to QR, and that angle QPS is congruent to angle PQR, because that was all given information to you. Okay, and then I see that that is a side and an angle, so I know I'm missing a side that has to be PQ because you have no other choice because it has to be the included angle, and I know that PQ is congruent to itself. Okay, so PQ is congruent to QR because it does flip over. Okay, and that is called reflexive. So then you can say that triangle QPS is congruent to triangle PQR by side, angle, side, because this was your your second side. Okay, and now explain why triangle PQT is isosceles. So you know that angle 1 is congruent to angle 2. From part A. So you know that segment PT is congruent to segment QT by the converse of base angles theorem. So then triangle PQT is isosceles. Okay? So that's all that you need for your notes today. Let me know if you have any questions.